Here are 10 weather stories you can listen to in English. Now, let's get started. Highest cloud on Earth. What is the highest cloud that can form on Earth? The answer is the noctilucent cloud, which appears at an incredible altitude of approximately 80 kilometers in the mesosphere. These ethereal clouds are typically observed in high-latitude regions during the summer, becoming visible after sunset or before sunrise when they are still illuminated by the sun from below the horizon. They are composed of minuscule ice crystals that form at extremely cold temperatures, below -123 degrees Celsius. While the composition of these clouds is known to be ice, the origin of the seeds or nuclei on which the ice crystals form has been a subject of study. The leading theory suggests that these nuclei are made of meteor smoke, which is fine dust created when meteors disintegrate upon entering Earth's upper atmosphere. This extraterrestrial dust provides the necessary surface for water vapor to condense and freeze, creating the beautiful high-altitude displays we see. Thus, these clouds are not just a meteorological phenomenon, but also a direct link to cosmic events occurring far above our planet. Megaflash Lightning. How long do you imagine a single flash of lightning can stretch? On April 29, 2020, a single lightning event over the southern United States set a new world record, extending for a staggering 768 kilometers. This megaflash covered a horizontal distance comparable to that between Tokyo and Hiroshima. Such colossal flashes are not the familiar vertical bolts that strike the ground, but are instead vast electrical discharges that propagate horizontally through massive thunderstorm systems, sometimes for hundreds of kilometers. The observation of this record-breaking event was a direct result of advanced satellite technology. Instruments like the Geostationary Lightning Mapper, GLM, now allow meteorologists to track lightning activity continuously over immense geographical areas from space. Previously, the true scale of megaflashes was underestimated because ground-based detection systems could only capture portions of such extensive events. This new satellite-based perspective has revealed the astonishing size that lightning can achieve, forcing a re-evaluation of the upper limits of atmospheric electrical phenomena. Bowling ball hailstone. Could you imagine a piece of ice the size of a bowling ball falling from the sky? In 2010, this became a reality in South Dakota, USA, when a monstrous hailstone set a new world record. This officially recorded hailstone measured 20 centimeters in diameter and weighed 0.88 kilograms, making it the largest ever documented. Such an enormous piece of ice can only be formed within a particularly severe type of thunderstorm, known as a supercell, which is characterized by exceptionally powerful updrafts. The formation of giant hail is a process of accumulation in extreme conditions. Inside a supercell, water droplets are carried by powerful updrafts, sometimes exceeding 160 kilometers per hour, into the freezing upper levels of the storm. As they freeze, they begin to fall, collecting more supercooled water before being swept upward again. This cycle repeats, adding a new layer of ice each time. The hailstone continues to grow as long as the updraft is strong enough to suspend its increasing weight. It finally falls to Earth only when it becomes too heavy for the updraft to support or is ejected from the storm's core. UFO-like cloud? Have you ever seen a cloud that looks like a UFO, hovering motionlessly over a mountain? These are lenticular clouds, and they form when strong, stable wind is forced to flow over a large obstacle, like a mountain range. As this moist air rises up the windward slope, it cools and condenses, creating the distinctive lens-shaped cloud. The most striking feature is that the cloud appears completely stationary, even in high winds. This is because it is in a constant state of formation and dissipation at a fixed point in the sky. This static appearance, however, is an illusion. The air itself is actually rushing through the cloud formation. The cloud forms continuously on the upwind side as air rises and cools, and it simultaneously evaporates on the downwind side as the air descends and warms. This process creates what are known as mountain waves, which can generate severe turbulence with vertical air movements exceeding 15 meters per second. For this reason, while beautiful to observe from the ground, pilots are trained to avoid these areas, as they can pose a significant danger to aircraft. Red rain from sky. Have you ever heard of a phenomenon where the sky appears to rain blood? In 2001, the state of Kerala in India experienced a series of startling red-colored rainfalls over a period of 2 months. This bizarre event, often called blood rain, initially caused widespread public fear and speculation. Scientific analysis later revealed the cause to be non-terrestrial. The red coloration was due to the presence of a vast quantity of airborne spores from a type of locally prolific terrestrial green algae belonging to the genus *Trentipolia*. While initial hypotheses ranged from meteorite dust to extraterrestrial cells, detailed investigations by scientists disproved these dramatic theories. The research concluded that strong winds had lifted the algae spores from local sources, such as trees and rocks, high into the atmosphere. These microscopic spores then mixed with moisture in the clouds and fell with the rain, giving the precipitation its distinctive and unsettling reddish hue. This event serves as a remarkable example of how local biological matter can be transported by weather systems, creating unusual meteorological phenomena. Winter thundersnow. Have you ever considered the possibility of hearing thunder during a snowstorm? This rare weather event, known as thundersnow, is a fascinating phenomenon where a winter storm produces both snow and lightning. It is most frequently observed in specific locations, such as the Great Lakes region of the United States. Unlike typical summer thunderstorms that are formed by surface heating, thundersnow is generated when there is a significant temperature difference, often more than 40 degrees Celsius, between the relatively warm surface of a large body of water and the extremely cold air mass moving over it. This instability creates the necessary conditions for lightning and thunder to occur simultaneously with heavy snowfall. A distinctive feature of thundersnow is its unique sound. The thunder often sounds more muffled and lower-pitched than in a regular storm, sometimes described as an explosive-like rumble. This is because the fresh layer of snow on the ground acts as an acoustic damper, absorbing the sound waves. As a result, the thunder from a thundersnow event typically does not travel as far as it would in summer. Unless the lightning strikes within a few kilometers, the accompanying thunder may not be heard at all, making the visual flash in the midst of falling snow an even more unusual sight. Lightning boosts mushrooms. Have you ever heard the old saying that a year with frequent thunderstorms leads to a bumper crop of mushrooms? This piece of folklore is actually backed by modern science. It has been experimentally confirmed that the electrical discharge, or plasma, from a lightning strike provides a significant stimulus to fungal mycelium. This stimulation drastically promotes the growth of fruiting bodies, which are the visible mushrooms we harvest. In fact, one research study reported that the yield of shiitake mushrooms nearly doubled after their growing medium was subjected to artificial lightning strikes. This fascinating natural phenomenon offers more than just an explanation for a folk belief. It holds promising potential for agricultural innovation. Scientists are now developing technology that generates high-voltage pulses to replicate the effects of lightning in a controlled environment. The goal is to apply this method to commercial mushroom farming to increase productivity efficiently and without the use of chemical stimulants. By harnessing this natural growth-promoting mechanism, this technique could pave the way for a more sustainable approach to cultivating one of the world's popular food sources. Kelvin-Helmholtz Clouds. Have you ever seen clouds that look exactly like painted ocean waves breaking across the sky? This stunning atmospheric display is caused by a phenomenon known as Kelvin-Helmholtz instability. It occurs at the boundary where two adjacent layers of air are moving at different speeds. When the upper layer of air moves faster than the lower layer, it effectively drags the top of the slower layer, creating a strong wind shear. This interaction causes the boundary surface to roll up into a series of vortices, which appear to us as a distinctive, wave-like pattern in the clouds. These clouds are considered extremely rare because their formation requires a very specific set of atmospheric conditions. A significant difference in both velocity and density between the two air layers is necessary for the instability to become visible. Consequently, Kelvin-Helmholtz clouds are often transient, lasting for only a few minutes before dissipating. While they are a spectacular sight for skywatchers, the underlying principle of this instability is not unique to our atmosphere. It is a fundamental concept in fluid dynamics observed in oceans, Saturn's bands, and even the sun's corona. Bun-Shaped Raindrop. Contrary to the iconic teardrop shape seen in drawings, have you ever considered the actual form of a falling raindrop? For drops with a diameter larger than 2 millimeters, the shape is far from a tear. As they descend, air resistance from below flattens their base, while the top remains curved. This results in a form that more closely resembles a small bun or the top of a hamburger. The classic teardrop image is a common misconception. Only very small droplets maintain a nearly perfect spherical shape due to water's surface tension. This phenomenon also explains why excessively large raindrops do not exist. When a drop grows to a diameter of about 5 millimeters, the force of air resistance becomes too great for the water's surface tension to counteract. This instability causes the drop to break apart into several smaller droplets. This natural size limit prevents us from ever experiencing massive single drops of rain, as they would disintegrate during their fall. Temperature-determined sex. Can the weather determine if a baby is born male or female? For some species, the answer is a definitive yes. In the case of the Mississippi alligator, the incubation temperature of the eggs dictates the sex of the offspring. If the nest temperature is below 30 degrees Celsius, all hatchlings will be female. Conversely, if the temperature is above 34 degrees Celsius, they will all be male. This phenomenon, known as temperature-dependent sex determination, TSD, is common among many reptiles. Interestingly, some statistical studies suggest a correlation between ambient temperature and human sex ratios at birth as well. This direct link between temperature and sex ratio has profound implications in the era of climate change. Scientists are concerned that rising global temperatures could severely skew the sex ratios of species that rely on TSD. A consistent increase in nest temperatures might lead to populations with a drastic overabundance of one sex, making it difficult for the animals to find mates and reproduce. This imbalance poses a significant threat to the long-term survival of these species, potentially increasing their risk of extinction.